Indonesia, rather than a scientific paper like this. First, I would like to, this is the topic, this is the title of my presentation right now, but I don't want to just talk about these topics. It is not interesting, I think, because this is my last research. So thank you very much for Professor Prakash that introduced me. That yes, you mentioned that I am Triyana from the Department of Physics, Faculty of Mathematics and Natural Sciences, Universitas Gadjah Mada, and this is the outline of my presentation. I would like to first show you about my university. So next time, if we have time and opportunity, you can come to my university and maybe we can visit your university and we can make a close collaboration. I think this is a very, very nice,
Thanks, sir. Thank you.
Yeah. And then I would like to introduce my research about the QCM based sensor for drug detection, because we start my research with drug detection, and then we continue, if I have time, to discuss about the QCM based sensor for gas detection in general, and also for humidity detection, and also developing the electronic nose. And you know that I want to talk more about the electronic nose right now, because I am now developing the electronic nose for COVID-19 detection just for a minute. And maybe if we have time, I would like to show you how the future research of in my laboratory. So let's start with my introduction of my university. I want to show you a short video. I'm sorry, this is in English. I hope you can understand.
As a world-class national university, Universitas Gadjah Mada is dedicated to the interest of nation and humanity. It delivers research, education, and community service by developing knowledge for the benefits of the society, the nation, and the world. We learn from each other, and we are strong together. Intelligence does not have true value when it cannot be shared with others. Learning processes will never stop because they are always evolving. Here, we learn by constantly exploring science, learning from history, observing the present, and researching for the future. We will always work hard and never give up. The learning process and research at Universitas Gadjah Mada continue to go together to discover new innovations. UGM built the Wisdom Park that can support the teaching and learning process. The park is an open space for the public. UGM also offers bicycles as a means of transportation within the campus that supports the creation of a conducive environment. Universitas Gadjah Mada has also developed drinking water facilities throughout the campus, a system that was provided by Toyagama Company. This is for the benefit of the entire academic community of Universitas Gadjah Mada. Students of Universitas Gadjah Mada in the course of study have the opportunity to apply the knowledge they have learned in college among community, increase their empathy or social life, and sensitivity to others as an example. Universitas Gadjah Mada students had the opportunity to do a community service program in Papua. In terms of disaster mitigation, Universitas Gadjah Mada produces qualified human resources with academic ability as well as professional planning and management skills in disaster management. We have played an active role in society by establishing a disaster response unit known as DERU. Knowledge development innovation continues in order to hone the students' skills during their learning process. This includes the development of mapping methods of disaster-prone areas that are difficult to reach. The Eliminate Dengue Project Indonesia has released mosquitoes with Wolbachia in several communities in Yogyakarta, a densely populated city that is a dengue endemic area. The purpose of this release is to proliferate Wolbachia among local mosquito populations to enable us to reduce the transmission of dengue fever to humans. We have real laboratories in the field for implementation of education and research. Gamma Herbal Indonesia Company produces and distributes research-based herbal and traditional medicine and utilizing harvests from traditional farmers. Learning and research about technology is strongly supported at Universitas Gadjah Mada. Many types of technology research have been conducted at UGM. Lecturers and researchers at UGM continue to conduct research in various disciplines. Forms of research in agriculture and animal husbandry also continue to be carried out in collaboration with industry partners. This is one of the commitments of Universitas Gadjah Mada. Innovate Academy, or IA, is a form of commitment of Universitas Gadjah Mada to turn its students into skillful young entrepreneurs through startup businesses. Challenges are what make life interesting. Success is a journey. It is hard work, through learning, studying, and sacrifice. But most of all, love what we do. Universitas Gadjah Mada maintains the unity of the nation by promoting national interests rather than regional and group interests. Universitas Gadjah Mada is a university of the people that fights for and promotes the interests of the people and the nation of Indonesia. As a university that has long been recognized by the public, we are proud of our strong tradition of tireless service to the nation and state. With delivering education, research, and community service being the main duties of higher education in Indonesia, we remain committed to always instilling the values of Pancasila. We will always try to protect the sovereignty of Indonesia in accordance with the state ideology of Pancasila and sustain the life of the nation democratically, whilst still maintaining the true identity of Indonesia.
We are UGM. We are UGM. Okay, thank you very much for watching. This is an introduction of my university. Actually, it's rather traditional compared to India, I think. But India and Indonesia is close friend. There are a lot of industry of India and Indonesia, and maybe vice versa. So I would like to continue my presentation. This one. Yeah. If you would like to know about my university, you can open this link. So it's very easy. It's a UGM, means Universitas Gadjah Mada. Yeah. First, I would like to talk about the drug detection. Actually, it is a big problem in developing country like Indonesia. There are many type of drugs, and it is not easy to overcome this problem. So we try last 3 years, I think we start this research, and we start from zero. I mean, we start from the development of device, and we develop the measurement system, and we develop the fabrication system. So before continuing my presentation, I would like to show you my activity in this year. In 2017, we start from the development of, sorry. I think so. Yeah, this is. Okay. Sorry, this is. I would like to start from my activity. Sorry. This is here. Yeah. This one, we start in 2017 to develop the QCM sensor. This is my first experience in developing of the sensor. We start from the development of measurement system. This is very simple measurement system. We try to produce from the very complex measurement system to the very simple measurement system, and then we do a calibration process, and then we try to apply to measure our devices. And we also develop like this. This is our experiment by myself. This is the system, very simple, and we record automatically like this. So using the system, we then develop the many sensor based on quartz crystal microbalance. So before, and also, okay, I would like to also to introduce you that we are also developing a ELTO. ELTO means electronic tongues for our tongue, like that, to detect the taste. So we apply in many applications. If you would like to study about the electronic tongue, you can come to my university later than when the COVID is already come from all the country in the world. And then this is my experiment during this is about the electronic tongue. Also, this is about the nano material application. We also applied my device in Portugal. In Portugal last year, we visited Portugal, and we employ one device called the electronic nose, and also we employ the electronic tongue in Portugal with Professor Prakas. We make a research collaboration between my country and Portugal, and later on I would like to make a collaboration with India and Indonesia, and we make some nice collaboration in research and technology. This is our activity last year before COVID-19 outbreak in the world. So yeah, this is some activity. Okay, I would like to continue with my presentation right now. So I just want to show you that start from 2017, we start from zero. We built the measurement system. We built the fabrication system of electro spinning system to fabricate the nanofiber of the polymer. Then we produce a saffron sensing. You know that saffron is the main material for making ecstasy. This is the most problem especially in Indonesia, because we can change the saffron to be many types of drug, and mostly it to be ecstasy. So this is a simple roadmap of my research project. Start from the producing the safflower sensing using PAN nanofiber. I will later on I want to discuss about what is the PAN nanofiber, and then producing the safflower sensor using PAN CS nanofiber, and then we produce the this is improvement of our system by using the PVAC polyphenol alcohol. Polyphenol acetate, I mean, this is nanofiber also, and then then we also to understand the characteristic, and then also to understand the sensing mechanism. We also analyze the effect of analytic vapor pressure on sensor sensitivity. So in this case, we also make investigation about the primary alcohol-analytic, also isomer butanol analytes, aromatic hydrocarbonolate, and so on. So I would like to start the drug detection. As you know, that the detection of illegal drug precursor, I mean, also remain a problem faced by law enforcement worldwide, especially in my country. So there are many studies have highlighted to need some development of better method for detection, because previously we used the VOC in health problem. I mean, some report we can see here that we can detect some drug synthesis reactant and so on by many what we call the conventional instrument. And there are some common precursor in the drug formation. For example, benzodioxole, and then BMK, and the last one is a saffron. So in this case, we focus on the saffron detection. This is a chemical structure of the saffron. Saffron means precursor for the production of the amphetamine type of stimulated drug or RTS drug, when we commonly known as ecstasy. This is a very, very popular one. And then how to detect one? Previously, some people report how to detect the saffron using classical analytical techniques like the gas chromatography, and the gas chromatography tandem with mass spectroscopy, and then liquid chromatography tandem with mass spectroscopy, and so on. I think the sensitivity, of course, the sensitivity and selectivity method is very high in the classical analytical instrument, but this is costly and challenging to operate the real-time application, because we need time to how to prepare some sample and so on. And also we develop many possible gas sensing approach, like resistive sensor, like chemiresistor, diode, and transistor devices, optical sensor based on surface plasmon resonance. We also developing this kind of sensor, and the piezoelectric crystal surface. This is including the quartz crystal microvalence in my works. And yeah, we propose how to develop the safflower detection with the quartz crystal microvalence QCM. Why? Because the development sensor detection system to detect is still open issues in this case. So if you open or shut in the Google, then we on maybe only me, my group, that you can find the paper that discuss about the detection of safflower based on QCM. Okay, this is just introduction of the quartz crystal microvalence. This is the quartz crystal microvalence, like case, very thin. It is about 0. I'm not sure, but this is a very thin, and this is diameter is about almost one centimeter more the diameter. So the student that the QCM was used published by Sorbre. It is very very popular ones. And then usually initially used for thickness measurement in vacuum chamber. For example, if you use the evaporate some material using a vacuum evaporator, and you maybe you use the sputtering system to make a thin film in the surface. You can control by the thickness measurement in using the QCM system. That's the initial one. But later on, we can use the quartz crystal microbalance to be the sensing one. I mean, the gas sensing application required a surface modification. And as we know that the natural characteristic of the QCMs depend on the what we call depend on the natural frequency. We usually use the 10 megahertz of natural frequency of the QCM, and then we can also use the signaling by the change of separate correction like this. So the change of the frequency is linear to the changes of the mass of analysis here. So this is some advantages of using QCM for a sensor platform compared to another platform and so on. But actually, we can write rapid and real-time detection, and I think this is cheaper rather than compared to another technique and a simple, not require reprocessing and so on. And this is another disadvantage using the quartz crystal microbalance. One is a high influence by environment changes and also low selectivity. How to solve the problems? The first one is to use the hydrophobic material. So if you use the hydrophobic material, so the material is not influenced by the environment changes, especially from the humidity changes. And how to overcome the low selectivity of the QCM sensor? We use the material interact with a specific analyte. We can show later in some my report. And I just to show you about the techniques to coating the QCM sensor with a polymer like this, for example, or maybe you can coat the material to improve QCM sensor performance using polymer, using metal oxide. You can use the functionalized material, for example, the single wall carbon nanotube and so on. And how to coat the QCM surface. You can use there are many type of techniques like spin coating, is tip coating, spray, and drop casting, sub-assembly, and so on. And this is the nanotube deposition, also nanowire and nanofiber, and so on. So right now we use the nanofiber one. Polymer nanofiber can be used for developing the sensor because it shows a large specific surface area, high porosity, interconnected porous structure like this. We have several. Then we have an acting as a Lewis acid like this, and we can just make some model like this. We have the chitosan molecule, then we can model that maybe it can be interact with saffron, for example. This is a chemical structure of polyacronyl and so on. Yeah. So the advantage to use as active layer on QCM sensor is to improve the sensitivity. Right now we just improve the sensitivity, not selectivity. This is also two important parameter of the sensor is the sensitivity, and the other one is the selectivity. So in this study, we use one is a polyacrylonitrile, we call PAN, and chitosan, CS, and polyphenyl acetate as PVAC. So the nanofiber used in the QCM sensor must be high mechanical stable, water insoluble, and hydrophobic one. This is a requirement for developing the sensor based on QCM. And how to deposit or how to make a nanofiber? We use this one. We use the electrospinning machine. We developed the electrospinning machine by ourselves and laboratory because it is very simple, just making a high voltage between the top of the shearing, and we collect the electrode here with the ground system. So the voltage is about 15 kilowatt, so very high, but the current is very low, sorry. So we can make like this. We can make a deposition of the nanofiber on the surface of your QCM. So in this study, we developed the PAN nanofiber using electrospinning and PAN, and then top with chitosan nanofiber. We compare between drop casting and electrospinning and polyvinyl acetate nanofiber using electrospinning, and we measure like I just show you that this is the lab-made measurement system after calibration. And then the lab-made oscillator frequency, this is one. This is lab-made oscillator and frequency counter. And from here, we can make a measurement like this. For example, if we insert the analyte and the liquid one, and we assume that all the liquid must be evaporated in the chamber, then we make a characteristic like this. Yeah, this is the effect of the interaction between molecule, fiber molecule, with the sensor in the surface like this. So it is very easy. And then this is some result, very thin. How long to make this type of sensor? It's just about 5 seconds, 10 seconds, 15 seconds, and 20 seconds. So it's very, very easy in this case. And then we characterize using our system, and then we can the sensitivity of the sensor like this. And I will to continue to the sensing mechanism, and we try to publish this paper in the sensor MTPE. So, for example, this is the illustration of the nanofiber of PAN, and then this is a analysis of several molecule, and this is a simple mechanism. So, intermolecular interaction also believed to be responsible for several detection using polymer nanofiber in this case. So this is our first detection of several system. And then we continue how to improve the selectivity. When the sensitivity of PAN nanofiber is relatively good, the sensitivity must be improved to better sensor performance. So the two important parameter, including sensitivity and selectivity. Right now, I want to show you how to improve the selectivity of the sensor. So for this purpose, we use the chitosan for, actually not mixture directly from the electrospinning one, but we just make a electrospinning with the PAN system, and then drop casting with the what we call the chitosan system like this. So we have no overlay from the chitosan, and we did this with the chitosan one. Still in Indonesia, we can show from the FTIR spectra. It is clear that this one is contain the chitosan one. Well, I would like to continue with this report. Then we publish in this journal. Another sensor. So here we can improve the selectivity rather than sensitivity. Yeah. And then we use another material that this is a hydrophobic system. So this is the PPAC. Yeah, we make a nanofiber also, but the structure is not really different from previous one. And here we can improve the sensitivity. Sorry, still Indonesia also 5 times. The sensitivity of the sensor is 5 times higher compared to the previous one. So then we also calculate the quality factor and to show you to check whether the equation is good for this application. This is a quality factor of admittance spectra. And this is our summary of the system, for example, PAC, PPAC2, and PLEX, and so on. So this is just another measurement of my projects. And then, okay, after we are developing the PAN with Kitosan and PPAC, then we show here that the sensitivity improved significantly from 4.5 to 18.7 to the last one is 248.2 hertz per milligram liter. That is the improvement. So the question is why this system is interesting for high sensitivity. So significant increase in PPA sensors sensitivity probable due to the ability of its PPA subunit to inter with 4 saffron molecules. So this is the one subunit of PPAC, and this can be interact with 4 molecules of saffron. So maybe it is the reason why this material is a very high sensitivity to the saffron like this. And then we also investigate another characteristic, and we check the sensor with the saffron. This one is very high in the sensitivity, and the sealant, formaldehyde, and other acetone, methanol, and so on. So we then conclude that the sensor is much sensitivity to the saffron rather than another analytes like this. And we also investigate the what we call the stability of the sensor. This is from 1 to 20 times of using the sensor, and we just change the about 5% of the changes of the sensor response. And especially the best one is the PPAC3. Yeah. So it is very interesting, I think, and we published in the scientific report last year. Then we also investigate the effect of the vapor pressure analytic to the sensor sensitivity like this. If we use the many various analytic alcohol primer, this is in Indonesia, primer alcohol analyte, I mean, like methanol, ethanol. This is a primary alcohol. And then the sensitivity of the sensor depends on the analyte one. For example, like this, the sensitivity of PPA is a nanofiber sensor is increased by the decrease of vapor pressure. But the sensitivity of the sensor decrease with increase the vapor pressure like this. And this is the group of primary alcohol. This is the group aromatic hydrocarbon. It is a group of butanol isomer, and so on. So this is also another knowledge of my our investigation. So from this study, we published 3 papers in some different journal, I think. So. Yeah, and this is another topic of our research about the dependence of the fiber pressure analyte to the sensor sensitivity, like this. So if you are interested in this topic of research, you can start by maybe reading our paper like this. We can show you later. And then, yeah, this is the summary of my talk about the effect of fiber pressure analyte to the sensor activity. And this means that if you understand, if you know about the pressure, fiber pressure analyte, so you can predict the sensitivity of the sensor. This is very interesting, I think. So it is very ideal idea that before doing an experiment, you can make some simulation, for example. You can make a list of the characteristic of the analyte with various of fiber pressure of analyte, and then you can predict which one is the good analyte for sensing in this material. And then, okay, we have many also some conclusion from this experiment that for high affinity analytes, the sensor sensitivity is high influence by the analyte fiber pressure, like this. Yeah. And then the second one, low affinity analyte produces lower sensor stability even when fiber pressure is low. So in the case of the QCM pulse sensor, the sensitivity of sensor does not depend only on the characteristic of the sensor material, but also depend on the characteristic of the analyte to be sensing. Okay. Then we published our paper last year, yeah, in 19, in many different papers. So yeah, I just want to show you some another investigation. This is a characteristic of the sensor. We obtained the sensor from the commercial one from Italy. And this is the characteristic of the sensor we use during the experiment. And then this is the characteristic of system of measurement. This is the measurement. And we developed by ourselves and so many data. And I just want to show you later about the another. Okay, there's many. Another paper. Maybe we start from here. Yeah, sorry. This is the new one, still in press, just published right now. We investigate the stability of the quartz cathode microbalance coated with the polyvinyl acetate, as I mentioned before, as a butanol and fiber sensor like this. You can short later with in Google, I think. And we also published this year. We try to understand why the quartz crystal microbalance is very sensitive to the humidity in the environment, in the ambient environment. So in this case, we try to coated the QCM surface with hydrophilic, this one, the polyethylene amine, grafted polyacrylonitrile nanofiber. And we have a very high sensitivity. Oh, sorry, this is very small. Very small. So small. Yeah, the sensitivity is relatively high. This one, I'm not sure, but this is published in this year. And we also published about the how to, as just mentioned before, that the primary alcohol can be studied, and we have more knowledge about the sensing mechanism of the sensor. And also we published in polyphenol acetate film-based microbalance for detecting benzene, toluene, xylene, pepper, and so on. And then we published in this last year, quartz-cadmium balance modified with polyphenol acetate non-fiber for short chain alcohol isomers. And also we published the, this is a last year we also published one, and also we published about the many modification of the QCM coated cellulose acetate nanofiber operated with quotation for detection of acetic anhydride fiber. And then we also published, this is the first, our first paper when we start developing the QCM based sensor, this one. And then, and so on, I'm not sure. Yeah, this is also our, after fabricating many types of the sensor, then we make unity to be sensor array. So we make a intelligent mobile electronic nose based on compressing of hybrid polymer functionalized quad-cadmium microbalance. In this study, we we detect or we make a detection of, I want to give you a more bigger this one. And this system can detect the many type of group of analytes. This is for alcohol one, this is for non-alcohol one, and so on. So that's very interesting. If you are interested in my this research, you can access in this system. And then this one, and we also published in another one. This one is also published in this year, 2020, I mean, quad-cadmium microbalance for fundanoside with citric acid top polyphenol acetate nanofiber for ammonia sensing. So it is also very interesting. And the next investigation, we would like to make a we would like to develop the sensor for detecting ammonia from the breath. So if we detect the ammonia from the breath with what we call the threshold, the minimum, the limit of detection is very low, so we can detect the illness of in our body. So this is the next project, I think. And then 2002 and so on. Well, I would like to continue my presentation with the development of the electronic nose. Sorry. This one. Yesterday, if you open the newspaper, you can find the Indonesian to introduce rapid breath test to detect COVID-19 infection within minutes. Fortunately, I'm here as a lead of the research team in this research to develop the system for detecting the COVID-19. And I want to show you what type of my Sorry. Okay. This one is yeah. Just to introduce you about the electronic.
Gadjah Mada Electronic Nose C19 atau Genos C19 merupakan alat inovasi Universitas Gadjah Mada yang terbaru dalam screening COVID-19. Genos C19 bekerja dengan mengenali pola senyawa metabolit yang terbentuk dari orang yang sudah terinfeksi COVID-19 hanya melalui sampel nafas. Langkah awal adalah menghidupkan alat Genos C19.
I'm sorry, in Indonesian, you understand? I hope so. But by watching the video, you can understand, I think. I hope.
Dengan cara berikut. Posisikan alat Genos C19 pada tempat dengan aliran udara yang baik dan tidak pada tempat yang banyak orang berkerumun. Pastikan mesin dalam keadaan mati, lalu sambungkan mesin Genos ke komputer dengan menggunakan kabel data dan sambungan listrik. Pastikan selang sampel menembus plug HME filter. Selang menembus minimal 1 mm ke dalam melewati plug dan tidak menyentuh bagian dalam filter. Sambungkan selang sampel ke port selang sampel, lalu selang reference ke port selang reference. Ujung selang reference diposisikan jauh dari tempat pengambilan sampel, seperti di bawah meja atau ke jendela. Kemudian tekan tombol power untuk menghidupkan mesin Genos. Kemudian buka aplikasi Genos AI Dashboard. Pastikan di layar laptop muncul Device Connected with Advanced Mode. Saat mesin sudah terhubung dengan benar, biarkan mesin hidup selama kurang lebih 15 menit untuk memanaskan mesin. Lalu setelah 15 menit, lakukan evaluasi mesin dengan menekan flush untuk evaluasi udara sekitar apakah sudah ideal untuk penggunaan alat. Saat flushing, udara ideal tergambar pada grafik dalam batas plus 20 mV sampai dengan minus 20 mV. Ambang batas udara yang tidak baik atau tersaturasi adalah di luar 50 mV sampai dengan minus 50 mV. Apabila udara tidak baik selama flushing, harap memindahkan alat ke tempat dengan sirkulasi udara yang lebih baik. Penggunaan alat Genos C19 didesain agar dapat digunakan dengan mudah dan efisien. Tidak hanya bagi tim medis, masyarakat awam juga bisa menggunakan alat ini. Berikut langkah-langkahnya. Tekan Analyze lalu lengkapi identitas pasien. Lalu persiapkan pasien untuk mengambil nafas. Pasien boleh berdiri atau duduk untuk pengambilan nafas. Pasien diinstruksikan untuk menghembuskan nafas ke dalam masker sebanyak 2 kali. Lalu, pasien diminta untuk menghembuskan ke dalam kantong nafas. Ingat, posisikan katup kantong nafas sudah terbuka. Instruksikan pasien untuk mengunci katup saat kantong sudah penuh. Kantong nafas lalu dihubungkan ke HME filter. Jangan lupa untuk membuka katup kantong nafas setelah terhubung dengan HME filter. Lalu tekan Save untuk memulai proses sampling nafas. Kemudian tunggu proses pengolahan nafas, dan nantinya hasil nafas dapat dibaca langsung. Pastikan loading kedua yaitu
So using this machine, we can directly know the status of our heart. This is negative with normal signal like this. It's very simple. Just less than 2 minutes, we can know the condition of the people.
loading flushing selesai. Alat bisa langsung digunakan untuk pasien selanjutnya. Setelah sampel selesai dianalisis, kantong nafas dibuang pada limbah medis. HME filter apabila sudah digunakan melebihi 100 kali subjek negatif atau 1 kali subjek positif, harap diganti dengan yang baru. HME filter dibuang pada limbah medis. Catatan peringatan, pastikan pasien tidak mengkonsumsi makanan, merokok, atau mengkonsumsi alkohol dalam periode.
Okay, I want to stop my presentation, and once again, I would like to show you some our activity. So you know that this is the newspaper yesterday, I think. Yeah, yesterday, and this is the Indonesian will soon introduce the new rapid test which can analyze blood sample and detect COVID-19 infection within a few minutes. Actually, fortunately, I am a leader in this research team. So this is our introduction about our activity. And this is the activity of this is a electronic machine. This is a commercial one. And right now, we are developing 10,000 machine in the next month, and we will develop to implement it in the some area. So using the 10,000 machine, we can detect about 1,200,000 people a day. So it is very, very huge of detection of the COVID-19 detection. This is a problem in our country that the detection of the people who are infected of the COVID-19 is very limited. So we developed the mass detection like this machine. So this is our activity, and this is what we call the troubleshooting. Yeah, we find some error here, and we provide many devices, and then we also develop the system of the sample, and this one is some result of our machine and so on. So there are many activity during the pandemic of COVID-19, and we go to some how to overcome the COVID-19, and especially in my country, or maybe next time we can help another country to overcome this problem of the COVID-19 outbreak. Okay, I would like to stop my presentation. I think this is my presentation. It is not actually the scientific one, but I just want to show you our activity, and maybe next time we can learn together and then make a research collaboration. This is enough. This for my presentation. Thank you very much.
Sir, thank you very much for your presentation, sir. It is very impressive. But a couple of videos are in your language, sir. So I hope other students.
Yes, I'm sorry. Still in Indonesia.
Students, you may interact with the speaker. I hope you all have some questions with you, right? You may ask one by one.
Sir.
Sir, my students are going to ask questions, sir.
Yeah, please.
Sir, am I audible, sir?
Okay, please.
Sir, what is the analyte in the COVID breathalyzer that your team has successfully produced? Sir? The analyte and the sensor coating in the Enos breathalyzer, sir.
I'm sorry. Do you mean that this is from the breath?
Sir?
Do you mean that the analyte from the breath? the detect. Okay. Yeah. Maybe I can yeah, a little bit understand about your question. As the name of electronic nodes mean the electronic like our nose. So our nose is not able to detect what kind of the analyte, but our nose can detect the pattern of the complex analytes. So in the system, the sensor array combined with artificial intelligence, then we can make a recognition of the pattern of the analytes and breadth of the COVID-19 patient and non-COVID-19 patient. This is just like the simple one. It is different from the, for example, the gas chromatography that you can detect the what is the analyte, what is the compound, and so on. So the electronic nose is just to make a pattern and then to be trained in the system and then to be tested with another patient. Like this, it's very simple. Yes, sir. Okay, another question.
Sir, good evening, sir.
Yeah, please.
Sir, why does polyvinyl acetate is able to sense more than polyacrylonitrile, sir, as you explained?
I'm not sure your question about
Sir,
electronic.
Slowly ask your question, ma. Priyadashni.
Sir, it is about the sensitivity you told about the sensor. Why it is
Yeah.
polyvinyl acetate shows high sensitivity than the PAN.
I mean, why the sensitivity of the sensor is higher than another sensor? Like
Yes, sir.
Okay.
Yes, sir. Correct. Yes, sir.
Yeah, it depends on what do you call pressure of the analyte. It's also depend. It also influence the sensitivity of the sensor. First, about the what do you call the pressure of analytes, and the second one is about the affinity of the analytes. As I mentioned you before, the sensitivity of the sensor is not only depend on the characteristic of the material itself, but also depend on the analyte characteristic, as I mentioned you, that including the pressure of analytes and also the how we call the affinity and also some parameters. So actually, you can make a prediction. What is the most suitable sensor if we have a specific material and we can make a check what is the most suitable analyte for detect. It's still a complex one, I think. Yeah.
Thank you, sir.
Okay. Yeah.
Sir,